Welcome to the Esri Emergency Communications webinar. And good morning, afternoon, or evening, regardless of your time zone, thank you for joining today's webinar. My name is Britt Bromley, and I'm part of the Esri Public Safety team. And my colleague Mike King is not able to join today, but he will be back for the next webinar. But I am joined by Ray Umali, who is the behind-the-scenes master of this webinar. So Ray, thank you very much for pulling everything together for today's presentation of the webinar. If any attendees have questions during the webinar, please enter them into the chat window where you logged in for the webinar. And if appropriate, we will be addressing questions at the end of the presentation. In some cases, there may be questions that we'll have to follow up after the webinar, but no fear that we will respond to all questions that are submitted during the presentation. About 2 weeks ago, as we wrapped up our annual user conference, and I haven't seen the final numbers, but I'm hearing we had roughly about 20,000 attendees, which will make our largest conference thus far. So I just want to thank you to all who attended the conference in San Diego and were able to join us. For those who were not able to attend and are interested in kind of getting a sense of the conference, the plenary is available to view on our website, and you can actually view it in different segments. So if you want to view different parts of it at your convenience, it's there to be viewed on the Esri website. And obviously, if you were there and you saw it and you want to go back and review it and revisit it, it's there as well. During the user conference, we got a preview of today's presentation during the emergency call taking and dispatch special interest group meeting. So I can tell you we are set for a great presentation today. Today we're going to hear about the NENA Enhanced PSAP registration and census. And to share this presentation, I would like to welcome Brandon Abley, who is the Technical Issues Director at NENA, and John Brosowsky, who is the VP of Innovations at GeoComm. So Brandon, I will let you take it from here.
All right, thank you very much. Hello, everyone. And as introduced, I am Brandon Abley. I am the Technology Director at NENA, the 911 Association. Next slide, please. So before I begin, I'd like to give some background on NENA and what we are. NENA is the standards, policy, advocacy, and education organization for emergency calling in North America and beyond. We have over 14,000 members and growing, and our technical and operational standards govern how 911 and NG 911, 112, 119, 999 systems work across the United States and around the world. And we are the only open standards organization dedicated to 911 and emergency calling issues. And one thing I would like to highlight right at this moment is our growing international work. NENA had initially started as a US-focused organization, but in recent years, in the interest of shared global standards, interoperability, and the growing influence overall, we have been doing more work internationally. For example, Canada has adopted the NENA I3 standard for NG 911, and we've been working with Europe and in other continents too. Next slide, please. So John will give more of a technical overview and introduction to the EPRC, but I'll give a brief overview and talk about our policies, and I'll follow up at the end with some more information about our policies. But the EPRC, or the Enhanced PSAP Registry and Census, is a secure web-based tool that contains contact information and boundary information for PSAPs in the United States. And for those of you unfamiliar, a PSAP stands for Public Safety Answering Point, and that is the location where your call is answered. In NG 911, it's more abstract. It's a service where your call is received. But for the most part, that correlates with the place that your phone calls are actually answered by a human when you dial 911. This tool allows PSAP personnel to locate and contact other PSAPs during unusual call transfer situations where PSAP contact information is not immediately available. And this is kind of an unusual case, but this does happen. For example, cell phone calls, when an individual dials 911 from a cell phone, their call is sent to the PSAP that correlates with the sector that is serving their cell phone. And sometimes that can be misconfigured. And you do have these cases where you receive a call from the other side of the country. And it's pretty common that along borders that PSAPs will have contact information for each other. I live in the Washington, D.C. metropolitan area, for example, and it's pretty common that between Alexandria or Fairfax County or Washington, D.C., or counties in Maryland, that you receive a call from someone on the other side of the river and they have contact information and they're used to transferring calls. But sometimes you end up in a situation where you need to transfer a call and you just have no idea what the PSAP should be in that location, and that's where this tool comes into place. The EPRC can be accessed by verified public safety entities, including telecommunicators. Those are the individuals that answer your 911 call. PSAP management, government organizations, and third-party applications with a valid need to access the EPRC. And John will give a practical example of something that we're working on right now. Next slide, please. So the EPRC itself, I would like to mention, by the way, that NENA has had a PSAP registry for about 20 years. And this is an upgrade, this is a new service, but we have been offering a PSAP registry for all 6,000 plus PSAPs in the United States for quite a long time. But the EPRC itself, our new service, is published as a hosted feature layer in ArcGIS Online. I think most of you on this webinar are probably familiar with the ArcGIS Online suite. The EPRC covers the entire nation. We have PSAP boundaries included in the EPRC, which, contrary to this slide right now, are not currently authoritative. That means that we have used the information we have available to make a best estimate as to what the service area for that individual PSAP is. Part of the maintenance of this program is to work with the PSAP community in the United States to update those boundaries so that they are authoritative. And sometimes that gets complicated in metropolitan areas, for example, where the boundaries for a municipality are jagged and irregular. But the tool allows a user to search any location in the U.S. and see PSAP contact information. And John will give you a demonstration of what that actually looks like. I believe at this point we are pausing for a poll question.
All right, so hopefully everybody can see the poll question. So the question is, are you currently aware and or a user of the NENA PSAP registration? So if you please take a few moments and select one of the two options. Once we tally some results here, then we'll share with everybody what the results are here. All right, so we're pretty much down the middle there, a little bit on the no side, but this is a great feedback. Shows that there's a lot of people who are either not aware, obviously, or using this registry. So thank you everybody for the response on this. So we're going to go back to John Brosowsky to continue this presentation.
Great, thanks, Britt. So first of all, I thought it would be useful to look at some specific use cases or some pictures of some use cases so it's a little bit easier to visualize. So Brandon was describing some scenarios where a 911 call could route to a PSAP based on essentially a very coarse-grained location. And the coarse-grained location may cover a larger geography, like a cell site coverage area or a cell sector coverage area. And so what this can result in is a 911 call routing to a PSAP based on the a best known available coarse grain location. And on the map that we see on the left side of the slide in this red dot with the blue shaded area, that represents a cell phone location that a carrier has been able to compute and potentially use for routing a 911 call. However, what we see is you see this sort of dash line and then this red dot that appeared on the lower left of the slide. In this particular example, this actually locates or presents or describes the location of the caller when this 911 call was actually made. So again, the 911 call could route initially based on a coarse grain location, and then after the call has been answered, it may be determined 30 seconds or more into the call, a more precise location for the caller. And in this case, if this purple line was a PSAP service area boundary, this could be a scenario where the 911 call routed to the PSAP on the east side of the map, and it needs to be transferred to a PSAP on the west side of the map. So this is just a kind of a simple example that demonstrates how a 911 call can be routed based on a coarse grain location. And the fine grain location actually locates the caller in a different PSAP. And by the way, this example on the slide, this is an actual 911 call. We were at a test call. We were actually standing in the 911 dispatch center directly behind the telecommunicator. We pulled out a cell phone and called 911 and then observed how the location technology worked. Basically, the first location that we got was very coarse-grained, and then after the call was answered, we were ultimately able to get a call or a location that identified the position of the call actually inside the building itself. So one of the reasons we were able to get a more fine-grained location was some work that NENA has done in conjunction with the FCC. They really started a number of years ago. And what happened was back in 2015, the FCC imposed some new rules on the nation's wireless carriers, stating that over a period of years, they were going to need to increase the accuracy and precision of the computed location of mobile phones that call 911. So those rules went into effect back in 2015, but I would say today we're beginning to see the fruits of those efforts. Some interesting things happened, specifically last fall in September, leading up to September 2018. Both Apple and Google announced that they would make device-based hybrid location, or location that's computed by the location services and mobile phone operating systems that look at a variety of things, including GPS, cell sites, Wi-Fi signal strengths, and other factors, and are able to compute great locations and positions for mobile phones that you're used to in consumer apps that you run on your phone, like, for example, are used by Uber or Domino's Pizza or whoever. And they announced that they would make these locations available to 911 call centers for the first time. So actually the way that this works today, though, is that the 911 calls still route to call centers based on coarse grain locations, and then these finer grain device-based hybrid locations that are calculated in part by sensors on mobile phones themselves. Those more fine grain locations are available only after the call has already been delivered to a PSAP and answered by a call taker. So it's after the call that you may determine that you need to transfer the call. Another example that I wanted to call out is the case of Uber. So Uber recently has added a 911 call button into the Uber Ride app. And so this is a convenient way to initiate an emergency call to 911 from within an Uber ride, just by pressing a button in the app. you can generate a native 911 call over cellular, and from that point on, it's just like a normal 911 call, like dialing 911 on your mobile phone. But Uber has some additional capabilities in that they know additional information about the caller, like, for example, the make and model of the vehicle that you're in for your Uber ride, the color of the vehicle, license plate numbers, and so on. And so in some cases, this information can be steered to 911 PSAP as additional supplemental information that may be useful or helpful in responding to your call. So that really leads to a case where if there's additional supplemental information that could be driven to a 911 PSAP, it's a case where borderless boundaries and a map of PSAP service area boundaries could be useful in geofencing the additional information that's calculated by an app service provider like an Uber to get it to the right 911 call center. So that's just another type of a use case. So if the goal is to create a nationwide database of up-to-date PSAP contact information that also includes PSAP service area boundary polygons in a map layer, how are we going to accomplish this? Well, this is going to be accomplished across multiple initiatives for the EPRC program. The first initiative is to update the PSAP registry with current contact information from PSAPs. So in some cases, some of the data in the current NENA PSAP registry may be out of date, and we're asking PSAPs to go in and check out their information and update it. Now also this time around, because this is an enhanced PSAP registry, we're asking for more detailed contact information and some contact information that doesn't exist in the current NENA PSAP registry as well. So this is a more detailed contact information database for 911 PSAPs, more detailed than the current PSAP registry. So the first initiative is to update the PSAP registry and to get as many PSAPs as possible registered in the new system. Ultimately, we'd like to get all the PSAPs in the country registered. Now, a second initiative will be to capture more detailed census data from each PSAP. And census data, you can think of it as maybe more operational characteristics of a PSAP, for example, how many call taker positions they have, what level of training is available and used at each 911 PSAP, and so on and so forth. And the census data, the idea here is that this information will be aggregated and then summarized for use by NENA, but also 911 system planners and also legislators. This could be a fantastic tool for understanding the current state of the nation's 911 system operationally, as well as it continues to migrate from enhanced 911 to next generation 911. So that's a second initiative. And then a third initiative, an ongoing initiative, will be to aggregate and coalesce a seamless map of authoritative PSAP boundary polygons nationally. And so here we will be asking PSAPs and 911 entities to contribute PSAP boundary information to the EPRC for this particular use. And as Brandon mentioned, we have PSAP coverage areas in the map already, but they are non-authoritative. They are geographic boundaries that we were able to piece together in most cases from locally available data. For example, if we know 911 PSAP covers an entire U.S. county, then the county boundary is a pretty good approximation of the PSAP's service area coverage. However, it's non-authoritative, and really we would like to obtain the actual real authoritative PSAP boundaries that are maintained by 911 PSAPs and their GIS teams locally, and to then aggregate and coalesce all of these into a seamless map that we can load into the EPRC. So those are three initiatives that will help us achieve the goals, objectives, and mission of the EPRC. So let's begin talking about the technology that's under the hood here and how we're going to deliver success across these initiatives. So the first element of the EPRC, really visible, externally visible element of the EPRC, is a PSAP community website. So this is a publicly available website. It's at nena.eprc.org. And this website describes, well, all about the EPRC, its goals and objectives, and its initiatives. And there are lots of places where you can click on various elements to learn more information about how the EPRC works. And there's also a request access button. So if you are 911 PSAP and you're not already registered for the EPRC, you can click the button, the big blue button at the top, and then that will give you instructions for how to sign up for the system. Now, the Esri technology that we're using for this part of the system is Esri's ArcGIS Hub product. And ArcGIS Hub provides a really fantastic mechanism for implementing a system of engagement between the National Emergency Number Association, the industry association, and then the broader PSAP community at large. So it's a system of engagement between the industry standards organization, NENA, and PSAPs across the country nationwide. And ArcGIS Hub enables us to operate and track various initiatives. And also the ArcGIS Hub website builder that's available in ArcGIS Hub just makes it really easy to create a web portal that PSAPs can access, see a little bit of publicly available information, but then also log in to access more sensitive information that's only available to authorized subscribed PSAP users and 911 users of the system. So the first part of this is ArcGIS Hub, and if any of you GS folks on the call haven't used ArcGIS Hub or the ArcGIS Hub site builder, I'd encourage you to take a look at it. It's really a fantastic tool for creating systems of engagements between an organization and then a broader community at large that may have many thousands of users. So ArcGIS Hub was the kind of the first piece, or the foundation of what's externally visible from the EPRC. So then the next piece was related to updating contact information in the database, as well as eventually collecting census information. And so for this data gathering process, we are using Survey 123 for ArcGIS. And Survey 123 provides just a terrific electronic survey mechanism where surveys can be published to an ArcGIS Online organization, but then made available to a community via a web browser-based survey form. And so the web browser-based survey form is a web form. It's a mechanism for PSAPs to log in and enter contact information about their PSAPs, or also to edit existing contact information about their PSAPs in the event that their contact information changes for any reason, such as somebody retires and somebody new comes and takes a position, or somebody's promoted or moves into a different position, or new staff is added, and so on and so forth. So some of the interesting things about using Survey 123 for ArcGIS is that all of the results from the survey, anytime anyone submits a survey form, the information is written into a hosted feature layer in ArcGIS Online. And so that directly integrates into the data management process as we're building and maintaining an EPRC database in an Esri geodatabase container. So some other great attributes of Survey 123 that we've used for the project are Survey 123 has the ability to create very dynamic and smart surveys. So these are surveys that react to user input as users are entering information and answering survey questions. So for example, one of the things that you can do in Survey 123 is set up very complete data entry field validators. So for example, if we have a field that's asking for an email address, and somebody types in something that's not a completely well-formatted email address, the field will turn red, and it won't, if it's a required field also, it won't allow them to submit the survey with incorrectly formatted data. And Survey 123 is great because it uses XLS web forms, or XLS forms. And so we can do these field validations using regular expressions that are entered directly into Microsoft Excel spreadsheets that are then used to publish surveys into Survey 123 for ArcGIS. So those of you that are familiar with regular expressions, that's what this gibberish is here on the Excel spreadsheet row in the rightmost column. But this is the regular expression that validates that an email address is actually formatted as a proper email address. So that's just one example. Another example of smart surveys that we're using are survey questions that actually respond differently based on answers to previous questions. So for example, in this case, there's a survey question that's asking for the mailing address for a 911 PSAP. And there's an option to tick if it's same as the physical address. But if it's not the same as the physical address, they can tick the next box. And then ticking the next box will expose a new question where the user can then type in or supply additional information. So we can do multiple choice questions, multiple select or single select multiple choice, and just lots of very complex surveys that will really help us build a complete EPRC that contains data that's well formatted and consistent across the entire database. So Survey 123 is proving to be a great tool for that particular use case. And of course, like all good surveys, it's got capabilities to provide feedback and not just a rating, but of course also comments. And we use the ratings and comments then to make alterations and tweaks and improvements to future iterations of the survey and future surveys as well. So Survey 123 is another fundamental component of the system for gathering information and updating information from 911 PSAPs in the EPRC database. So then the next part of the system is the database viewer. And the database viewer is a web application that was built using ArcGIS Web App Builder for ArcGIS Online. So it's a configured web application that's available to authorized PSAP users in the EPRC. And it's a web application that exposes the EPRC contact database as well as the map layers, PSAP boundary polygons in the EPRC database as well. So it's got, of course, everything that you would expect on a web map: interactive search functions, database search features, filters, measuring tools, base maps, geocoding, just all of the basic applications in a web application, but all tailored for discovering PSAP contact information at any location anywhere in the country. And so if you look at this, there's several different ways that you can obtain PSAP contact information. So the first way is just to zoom in anywhere on the map and click on it, and then you can see exactly where the user clicked. You can see what the PSAP is and what the contact information is. We've got the actual contact information is blanked out, just because in this example, because we consider the PSAP contact information to be sensitive. We don't want PSAPs to be spammed by telemarketers or robocalls and those types of things. But you get the idea. You can click on the map, and anywhere you click on, you can see PSAP contact information at that particular location. Now, of course, you can also just start typing into the search box. And for example, in this example, we started typing the letters STEAR, and the automatic suggestion dropdown as we're this automatically populates as we're typing, but it tells us that, well, there is based on those 4 letters that we typed, there's actually a PSAP that matches those letters in its name. In this case, it's the Stearns County Sheriff's Office PSAP. But also, in addition to searching the text that you type in against the PSAP database itself, it's also searching against Esri's nationwide geocoding services and ArcGIS Online. So it's searching for street addresses, common place names. For example, it's suggesting Stearns Drive, Stearns History Museum, Stearns Way, a street, and so on and so forth. So it's very easy to just type in locations or common places or PSAP names to get to a particular location on the map. You could even type in a latitude, longitude coordinate, and it would take you to that spot on the map and reveal the PSAP contact information at that particular location. So if you let's consider a specific scenario. So in this scenario, maybe a little bit of a contrived scenario, but it's useful for illustrative purposes. In this case, let's say that there is an emergency incident near the Gateway Arch in St. Louis, but it's in the river. It's maybe a boating accident or something like that. And we have a question about PSAP contact information in this scenario. So in this case, the user can begin typing Gateway Arch, and of course this is just hitting the Esri geocoding service. We get a variety of suggestions as we're typing. And so in this case, the user selects, I'm looking for Gateway Arch, 200 Washington Avenue. So that's the one we want. And then, of course, the user can select that option, and the map will zoom to it and add a marker to the map at that particular location. So now at this point, the user can simply begin clicking around the map to reveal the PSAP contact information at this particular location. And this is somewhat interesting because we can actually see that depending on where you click in the river, you get a different PSAP. So if we click on the west side, St. Louis, Missouri, but if we click on the right side, we see St. Clair County, Illinois. And if you look, we also have a state boundary in the middle of this example as well. So very easy to determine PSAP information in these types of scenarios. So you can imagine cases where a 911 call routed to St. Clair County based on a coarse grain location, and after talking to the caller, we realize it actually needs to be transferred to a neighboring PSAP. And so very easy to identify that on this particular map. Now, just to be clear, this is a bit of a contrived example. I guarantee that these two PSAPs know how to transfer calls back and forth very easily. But as Brandon mentioned, there can be scenarios where in these transfer situations, the PSAPs aren't right next to each other. They may be separated by multiple PSAPs in between, and they may not be as familiar with these geographically distant PSAPs because they don't transfer calls to them as often. And again, as Brandon mentioned, these can even be PSAPs that are separated across entire states or even on different sides of the country. And there's just lots of different examples as we look at routing wireless calls, but also 911 calls, text to 911 calls that are supported in some but not all jurisdictions, 911 calls made from voice over IP soft phones, but also just scenarios where you call 911, but you're reporting an emergency that's occurring somewhere else. So for example, you may be talking to a colleague or a family member on the phone on the other side of the country. That individual maybe has a medical emergency. You hang up the phone and call 911. Well, your local 911 PSAP will get the call, and then you'll need to describe where the emergency is occurring that may be across the country. So in that scenario, this type of a tool could be very useful to just simply, you would tell the 911 call taker where the emergency is occurring, and they could type that location into the search tool here, very easily find the correct PSAP contact information, and then take some actions as a result. So that's an example. There's a So I would say that NENA also envisions adding more types of service area boundaries to this database over time. And one example of this would be U.S. Coast Guard Rescue Coordination Center regions. So going back to our boating incident example, by turning on a U.S. Coast Guard sector boundary layer, now we can also click on the map and identify the U.S. Coast Guard RCC that would be responsible for this particular marine incident, as well as a 10-digit phone number for contacting that RCC. And again, because it's a nationwide map, you can click anywhere in the country to determine a Coast Guard RCC that would cover a particular area. You can imagine other types of emergency services as well where this could be useful. So another element that I wanted to describe a little bit was maybe some less tactical use cases. So those are all very tactical and operational use cases where some type of an incident is occurring and a 911 call center needs assistance in determining correct contact information for a PSAP in a particular geography. But there may be less tactical and operational use cases as well. So for example, let's say a 911 entity is in the middle or about to enter into a procurement process. Maybe they're procuring a new computer-aided dispatch system or some radio equipment or something like that. And they would like to collaborate with their peers to see what similar PSAPs have done in the past or how similar PSAPs to themselves have solved particular problems. So in this case, this could be useful to identify contact information for 911 PSAPs near your own, or also potentially PSAPs that have similar capabilities as your own PSAP or similar sizes. Certainly for 911 system planners, this could be useful information as well. When we talk about tools for planning, even at a federal and legislative level, it could be useful to identify PSAPs within congressional districts even. So for example, there's some tools here where you can specify a specific congressional district and then see all of the 911 PSAPs that are in that particular district, along with representatives whose offices you may need to contact. So this screen here describes how we're using some Esri ArcGIS Online web application builder widgets to make the EPRC searchable in this way. In this case, we're using the filter widget, so we can filter based on states, state name, in other words, show me all of the 911 PSAPs in Iowa, or we could filter by a NENA region. So NENA has the current PSAP registry broken up into several different regions. So if you're a current user of the NPR and you're used to dealing with NENA regions, it's very easy to sort the PSAP registry in that manner. And then, of course, our congressional district support as well. Now, in addition to that, this information, of course, all displays in a feature data grid at the bottom of the map. And you can actually filter on any field in the EPRC that you want, not just these pre-built filters. The pre-built filters just make it an easy way to provide us really a one-button click to filter the EPRC database based on the most common types of searches and filters that people want to perform. Certainly, we may add more of these one-button filters over time, but these are just sort of the initial set of filters that were added in. So again, using the feature data grid, very much like an Excel spreadsheet, in that you can sort and filter and click any row in the grid, if you will, and zoom to it on the map. And it's just another handy way of interacting with data in the map. So another capability of the system, because we're built on the because it's built on ArcGIS Online, is the ability to programmatically query the EPRC. So authorized entities can query these REST endpoints directly for various types of information. So this is an example, really an abbreviated example. This probably looks familiar to some of you. This example is not actually complete. It won't work if you click on it, and that's intentional. But I mean, you can see in this case we're querying based on a PSAP name and getting back 24/7 contact phone number for that particular PSAP along with a contact name. So there are some use cases where it could be useful to programmatically query the EPRC for data. One use case that NENA is working on right now is to use the EPRC API to expose a list of contact phone numbers that are registered in the EPRC to a RoboKiller web service. A RoboKiller is a service that can prevent automatic robodials or spamming of phone numbers, for example. So it can be, obviously you don't want a PSAP supervisor to be spammed with calls for extending their automobile warranty constantly, like I do on my personal cell phone. And so the API provides a way for third-party systems and services like RoboKiller that are authorized to interact with the EPRC database to do exactly that, but not as human users, as machine-to-machine programmatic level types of queries. There may be other examples where programmatic queries could be useful. We could, for example, see, for example, computer-aided dispatch applications running in 911 PSAPs. We could see those applications having the ability to programmatically query the EPRC API in certain scenarios to pull back information and to display it for a 911 call taker or dispatcher directly in their own application, their CAD application they're using operationally on a day-to-day basis, so that they don't have to log into the separate EPRC web application to query for information. So it's better to have as few applications as possible rather than many different applications that people have to log into and interact with. So the EPRC is a programmatic API that enables that type of access. We're actually really interested in hearing about thoughts and ideas and use cases that people have for API access to the EPRC so that we can evaluate those and think about how to structure API queries. And so we can also think more about how to extend and improve the API query service for these types of use cases. So we're really interested in gathering those use cases so we can take a look at them. So at this point, I would like to turn it back over to Brandon to talk about some policy types of issues related to the EPRC.
Yes, so thank you, John. Yeah, so the figure in front of you shows an overview of sort of the life cycle of the EPRC as a service. One of the important things that we really need to stress to our PSAP audience and also to any third-party integrators that might want to interface with the API is that at launch, our PSAP boundaries and our contact information is based on the best information we have. With respect to the contact information for the PSAPs, that is pretty good because we've been maintaining the legacy PSAP registry again for a couple of decades. The platform is quite old now, but we've been offering this service for a while, and the basic contact information we feel fairly confident about. But the additional fields that have been added to the EPRC that were not in the legacy PSAP registry, we have nothing for. And so we need each PSAP and each 911 authority to participate. The PSAPs can update their information at any time, and that's going to be a big part of maintaining this as a service, is not just migrating our user community over to the new platform, but in really working with the community to fill out all of the new fields and to update any old or out-of-date information. And very importantly, to have our boundaries updated by the 911 authorities that manage them. The 911 authorities across the United States are doing some of this work with respect to their boundaries for next generation 911 purposes. So we already have some places where an entire state, for example, says we've finished this project to put all of our PSAP boundaries in GIS for next generation 911. So where do we send the shapefile? So that's very promising. But there are hundreds to thousands of 911 authorities and over 6,000 PSAPs in the United States. So it's going to be quite a heavy lift. Next slide, please. So it's important to note that the EPRC is free to access for any verified PSAP personnel and generally for any government officials. It does not cost anything to access for the direct 911 call taking and management community. If you have an account for the current registry, you will receive an invite for the EPRC soon. If you are watching this webinar in the future, you may have already received that invite by email. If you need access now, if you'd like to participate before the full launch, feel free to contact us at 911EPRC@NENA.org. I will note through this webinar that I have seen we have already received some of those requests from individuals attending this meeting, so thank you. You can find the landing page at EPRC.NENA.org. If you have an account, that is where you log in. If you do not have an account, that is where you'll find more information on how to request one. And if you are a public safety entity or some other entity with a public safety interest with a need to access the API, please contact us. We'd be happy to work with you. Okay, thank you, everyone.
And I would also just like to add, for general inquiries about the EPRC, feel free to send an email to EPRC_support@geo-comm.com, and we'll be happy to moderate questions that come in via the support line, along with Brandon and the team at NENA as well.
That's excellent. Thank you, Brandon and John. I really appreciate a great presentation. So before we let you go, we do have some questions. So I want to pitch a few towards your way to get some feedback. So, and again, as I mentioned in the beginning of the webinar, there's additional questions that we received through the webinar. I'm going to try to address a couple right now with Brandon and John, but there's others that we will follow up with those individuals post-webinar. So the first one kind of ties to that last slide, I think, really around the policy slide. And the question was, can I access the registry if I am not a 911 PSAP?
So I'll be happy to take that one. Yes, there are many cases, and we have those same cases with the legacy registry. I want to stress that the PSAP registry is not accessible for marketing purposes, and any entity that gets access to the registry and misuses the information is violating our terms of use. But we have many entities inside and outside of government that do use the registry information and plan to in the future. Crisis hotlines, for example, wireless carriers all have access to the EPRC. We have officials with the federal government and the state governments that access the EPRC. So it is not just PSAPs directly, but the broader 911 community.
That's great, because I think that actually kind of dovetails to another question. It was actually a couple questions that came in that kind of tied to some of the last slides that you were presenting, and it was, and I'm going to paraphrase here, and hopefully it makes sense, but does each PSAP need to register, or can a county, for example, work with many PSAPs and represent those that many? So if, let's say, there's a county working on, they're working together, would each PSAP need to register, or the GIS manager for that county that might have 10 or 20 PSAPs, would that individual be able to represent the multiple PSAPs? Does that make sense?
Yes, absolutely. We issue credentials to individuals, and so those individuals may represent any one of a variety of roles. Telecommunicators that work on the floor will have a credential, for example, so that they can have the EPRC up on a screen when they need to use the database viewer during live operations, but also the GIS manager for the county or for a group of counties or for the state may also have an individual account. And we do understand that there are those cases where the GIS is managed at a higher level for our group of PSAPs. And yeah, of course, the individual responsible for the information for that group of PSAPs would have their own credential.
Great, thank you. A question that came through a little bit earlier, I think through John, when you were going to the initiatives, the 3 initiatives. The question was, is there a rough time frame when the PSAP boundaries will be deemed authoritative?
So the answer is that's not really knowable at this point in time, but it will gradually occur. And so what we'll do is we'll be adding an upload mechanism to the EPRC website where GIS entities associated with 911 authorities can upload PSAP boundary information. When we have a few 911 authorities across the country that have done that already, sort of in a beta or a test mode. So soon we'll open that up nationally. And then what we plan to do is to identify on the map which PSAPs boundaries were received from an authoritative source or are deemed to be authoritative, and which ones are not. And there again, Esri's ArcGIS web app builder and web maps actually provide a great tool for that, because we can use arcade expressions in web maps to expose features like clicking on a map and then you get a red indicator up on at the very top that says this boundary is not authoritative, or a green indicator that indicates that a boundary is authoritative. So it'll definitely be visible in the EPRC. Users will know if a boundary that they're interacting with visually on the map is authoritative or not. But we don't have a specific date when 100% of the boundaries will be authoritative, gathered and authoritative. It's just not knowable at this point.
Okay.
Yes, and this is Brandon. I have to add that also really depends on where you are or where you are asking about. John's home state of Minnesota, for example, the state has put together very good GIS data for the whole state. And so in markets like that, we might have authoritative information very soon, but there are so many different 911 authorities and government entities responsible for 911 in the country that it's not equal everywhere.
Understood. Great. So let's one last question, then I'll have a couple of final closing comments here. But the last question that came in earlier was: Is this registry an ECRF, a forest guide, or an agency locator service?
No, it's no, and not at this time. I understand that a lot of the functionality looks similar, or when we start to talk about having a web service that can process a query to identify a PSAP at a location, that it starts to look like certain things in next generation 911, but that is not what the EPRC is offered for right now.
All right, thank you. So thank you for your responses to those questions. And again, there were some additional questions that were received, and we will follow up with those individuals post-webinar. Before we sign off, I do want to mention that today's webinar is being recorded, and the recording will be posted on the Esri Industry webpage. And we will also be sending a link to all the attendees for the recording. So again, you can review the webinar, and if you have colleagues that didn't have the opportunity to attend, they'll be able to view the webinar at a later time. Also, you know, if there's anyone on this call that has general question about their Esri account or looking to connect with their account manager, please let me know, or I'm going to say specifically Mike King, whose contact information on the page right now that you're viewing. So we'll definitely follow up with any Esri specific account questions you might have. So lastly, again, I want to thank Brandon and John for your time today, and I want to thank everybody who attended the webinar today. I really appreciate everybody taking an hour of your time and joining us. So on behalf of everybody at Esri, I hope everybody has a wonderful day.